Hello and welcome to this lesson on ionic bonds. In today's lesson, we will first understand the process of ionic bonding between metal and non-metal atoms. We will then learn to recognize the formation of ions and their electronic structures in ionic compounds, which resemble that of noble gases. Finally, we will cover how these ionic bonds are formed through electrostatic attraction between the ions. By understanding the formation of ions and their electronic structures, we can gain deeper insights into the stability and reactivity of different substances. This will help us appreciate the patterns and behaviors of elements found in the periodic table, enhancing our overall grasp of chemical principles. Let's look at an example before we break this down. Consider sodium, a metal, and chlorine, a non-metal. Sodium has 1 electron in its outer shell, and chlorine has 7 electrons in its outer shell. Sodium will lose its 1 electron to achieve a stable electronic arrangement, forming a positive sodium ion, Na+. Chlorine will gain this electron to complete its outer shell, forming a negative chloride ion, Cl-. The strong electrostatic attraction between these oppositely charged ions forms an ionic bond, resulting in the compound sodium chloride, commonly known as table salt. So, ionic bonding occurs when a metal and a non-metal atom interact and exchange electrons. Now, let's break this down to examine the process of ionic bonding. Firstly, let's focus on metal atoms. Metal atoms, generally found in groups 1 and 2 of the periodic table, have relatively few electrons in their outermost shell. Because they seek stability, metal atoms tend to lose these outer electrons. When they do, they form positively charged ions known as cations. For instance, a sodium atom, Na, from group 1 can lose 1 electron to form a sodium ion, Na+. On the other hand, non-metal atoms, typically found in groups 6 and 7, have more electrons in their outer shell and need a few more to reach a stable electronic configuration. Non-metal atoms gain electrons and become negatively charged ions known as anions. For example, a chlorine atom, Cl, from group 7 can gain 1 electron to form a chloride ion, Cl-. Let's focus now on structure. The loss and gain of electrons between metal and non-metal atoms results in the formation of ions with full outer shells. These ions achieve electronic structures that resemble those of noble gases, which are the elements in group 0, or 18, known for their stable and unreactive nature. Consider the sodium atom. It has 11 electrons arranged as 2, 8, 1. When it loses 1 electron, it becomes a positive sodium ion with a new electronic structure of 2, 8, resembling the noble gas, neon, which has a stable structure. Now think about the chlorine atom, which has 17 electrons arranged as 2, 8, 7. When it gains 1 electron, it becomes a negative chloride ion with an electronic structure of 2, 8, 8, similar to the noble gas argon. After the exchange of electrons, the resulting positive sodium and negative chloride ions are oppositely charged. These opposite charges create a strong electrostatic attraction between them, which is the essence of ionic bonding. This attraction pulls the ions together, forming an ionic compound like sodium chloride. Ions in an ionic compound arrange themselves in a repeating 3-dimensional pattern known as a lattice structure. We will further explore lattices in an upcoming lesson. So in today's lesson, we delved into the process of ionic bonding, which is how metal and non-metal atoms interact to form compounds. We learned that metal atoms tend to lose their outer electrons to become positively charged ions called cations. Conversely, non-metal atoms gain electrons to become negatively charged ions known as anions. We then explored how the transfer of electrons between these atoms leads to the formation of ions with full outer shells, adopting electronic structures that resemble those of noble gases, known for their stability. Finally, we covered how the opposite charges of the new ions create a bond through electrostatic attraction, pulling the ions together to create ionic compounds like sodium chloride. Well done today. See you next time.